Hello, welcome to a video that covers section 1.3 regarding analyzing functions and piecewise functions. Now the notes that I handed out today in class actually did have some pre-calculus BC honors stuff, which we should ignore. So the first page we're going to completely ignore from the notes. So you can just kind of just sort of cross that off. So just kind of cross that off as well. It's not really what I want to focus on with today's video here. Cross that off. Cross that off. But on the second page, where it talks about graphing piecewise functions, that I do want to talk about. Now, we did do example 3 in class, where we graphed y equals 2x minus 1, and we graphed y equals 3x plus 1. But we did it based upon the inequalities right next to them. So 2x minus 1, if you were to graph it, would look like this. Y-intercept of -1, slope of 2, there's the line. But then we didn't want that whole line, right? We wanted a piece of it. The piece of it when x is less than or equal to 1. So then I erased part of the line. Of course, I just erased the whole line because I can't really erase just a portion of it, given that I'm working on a computer screen in this manner. But if you do plug in 1 for x, y is 1, which is right here. And of course, it's going to the left. So that would be the piece of the graph I want to show for 2x minus 1. For 3x plus 1, y-intercept of 1 up 3 over 1. Now if you plug in 1 into that one, we should get 4. But it's going to be an open circle with a slope of 3. And you have that. And so that's how we graph that piecewise function. Now domain is easy. That's all real numbers. We see all x values are covered. You're not excluding any x values over here. But the range is interesting. Definitely, we're covering all negative y values up to, and then of course we go up to 1. 1 being included. And then we see that we have 4, but 4 is not included, and then goes towards infinity. So that's what's happening with example 3 here. And we did talk about example 3, but we didn't do the domain and range. So now I'm doing the domain and range for example 3. Let's ignore this example for now, and let's move on to example 4. Now example 4, we have 3 equations, x plus 1, and -1, or they're expressions technically, but y equals x plus 1, y equals -1. Those are 3 equations. So I want to start at -1 for y equals x, which is going to be right there. If x is -1, y is -1, but it's an open circle, and of course it goes in this fashion. X plus 1, if I plug in -1, I get 0. Plug in 0, I get 1. Plug in 1, I get 2. Plug in 2, I get 3, and they're all included. Then, when x is greater than 2, I think I did it right, yeah. When x is greater than 2, we'll start at -1. And then go to the right. And that's how you would graph this piecewise function. Domain and range is still all real numbers. For domain. Range, definitely we're covering up to -1. -1 is actually included because of that line right here. And then united with from y equals 0 to y equals 3. We're looking at y values for range. Okay, go on and try example 5 on your own. You probably might want to pause the video. Of course, I'm not going to sit here for 2 minutes or 3 minutes waiting you to graph it because I got better things to do with my time. But, pause the video, try example 5, graph each line, see how it looks. and then see if your graph matches with mine. Okay, hopefully your piecewise function looked like that. Domain's still all real numbers. We're not skipping anything over. Everything's being covered here. Range, the lowest point is, of course, -3 for y. And it seems like it just goes up forever because it's heading in that direction, so nothing kind of gets passed over. In fact, we can kind of just sort of do it like that, and we're good. By the way, for your piecewise functions, they should always pass vertical line test. If you're getting a piecewise function that kind of looks like this, that's kind of not good because that failed the vertical line test. Okay. For the most part, I think you guys kind of get what's happening here, so we'll skip example 6 and move on to example 7. I'm just going to make up okay. Let's try this again. Kind of failed here. Okay. So you have to write a piecewise function for this. Now, we do see that we have 3 segments, and we see that the intervals are going to be from -4 to 0 for the first one, and apparently they're both included. Then it's between 0 and 4 for the next one, but 0 is not included, or 4 is. And then, of course, it looks like x is greater than 4 for the last one. The equation for the horizontal segment, 1, 2, 3, 4, 5, is y equals 6. That's easy, get the middle one out of the way. Here we see the slope is up 4 over 4. So slope is 1 with a y-intercept of 4. And then lastly, we see the slope here is -1/3. And the y-intercept is actually going to be a little tricky. Actually, I was not very smart how I did this one, because it's going to be a weird fraction. So if you go up 1, right, left 3, I think, and we'll work on the efficient way you can do this, I think it's going to hit at 5 1/3 for the y-intercept. And we could talk about that later. Because I'll make it so that you can easily locate it by just working backwards with the slope. But what you could do, I guess, is y equals mx plus b. Slope is -1/3. You do have a point on the line that you know, which is 4, 4. You can solve for b. 4 plus 4/3, which of course is 5 1/3. So looks like I was right about that. So if you're given a graph, you can actually state the piecewise function based upon that graph. Now our domain is not all real numbers. It starts at -4. It goes forever towards infinity. And the range here apparently goes from 0. Actually, it will go all the way down towards -infinity. So it's going to be from -infinity to 4. And 4 is actually included. And then, of course, unite it with plain old 6, because y equals 6 for sure over here. But anything between 4 and 6 obviously is not covered by the graphs. And remember, this line's going down, so you do have from negative infinity to 4. So we'll practice this later in class tomorrow. So I'm not going to do an example 8. Let's look at example 9 and wrap up the video, because I don't like to make these videos too long. I'm sure you guys don't either. F is 0. Plug in 0 for x. I'm going to go with this one right here, because 0 is definitely less than 3. But if I do, like, say, C, for example, F of 10, 10 is greater than 3. So I'm going to go with the top one, 30 minus 2, which, of course, is 28. Go and try B and D on your own and tell me what you get. You may want to pause the video. Okay, here's what you get. Half times 2 plus 4 is 5. You got to use the bottom one because 2 is less than 3. I'm still going to use the bottom one because x is less than or equal to 3. Half of 3 plus 4, of course, is 5.5. If you do the other ones, they're also less than 3, so half of negative 2 plus 4. That's going to be 3. F of half, that's 1/4 plus 4, that's 4 1/4. Okay, so that's kind of review of piecewise functions. If you're still a little confused about this, because it is a little tricky, we are going to do some practice problems in class. We're going to talk about this video. So if you do come to class and I was so confused, that's okay. Not a problem. Of course, we got it. That's great. But if you're still confused, not a problem. At least I want to kind of give you a chance to watch this video, think about it, and then have a discussion about it tomorrow in class, so it's not anything that's kind of brand new to you. Okay, I think we're all set. Enjoy the rest of the evening.